Hello, this is Miss Morningstar. Be quiet. Today, we're still working on solving systems of equations. This time it's using the equal values method. Don't forget, a system of equations is two or more equations. It's actually with the same variables. I don't think I included that in the first definition I gave you, but that's what it is. So, when you set the two equations equal to each other, you are using the equal values method of solving a system of equations. So, like for example, if you have y is equal to 4 plus 1 and y is equal to 5. If this is equal to y and this is equal to y, then doesn't that mean I can set them equal to each other? Because 4 plus 1 equals y, and 5 equals y, and if these are the same, then 4 plus 1 equals 5. And that's all the equal values method is. Alright, so we're just going to do a couple of practice problems, then I'm going to give you one to practice on your note page. So, solve the following systems of equations using the equal values method. What's a system of equations? Two or more equations together. Hopefully you got that. Okay, and some of you can look at this. Don't forget the solution is any values that make the equations true. So some of you can look at that and tell what the solutions to the system are. A is 5. Well, if A is 5, what is B equal to? If you know, great. If you don't, that's okay. So, using equal values, if A is equal to 5 and A is equal to B plus 3, if these two are both equal to A, then doesn't that mean you can set them equal to each other, which is why it's called the equal values method. So if A equals 5 and A equals B plus 3, then that means 5 has to equal B plus 3 because these are both equal to the same thing. And at this point you should know what the solution is, because what number plus 3 gives you 5? 2. Okay? If you can't do it, it is a one-step equation. You can just go like this. So the solution to this system is A equals 5 and B equals 2. You can write it like that, or you can write it like this. Because if I put a 5 in here, 5 equals 5. Here, I'll show you. If I put a 5 in for A, 5 equals 5. If I put a 5 in for A and a 2 in for B, that also checks because 2 plus 3 equals 5. Alright, so we're going to do one more using the equal values method, then I'm going to give you one to try, and yes, you will have to turn it in to me whenever I see you next, the next day of school. I don't know what day that is, because I don't know what day I'm giving you this video. So, in this case, you have y is equal to 2x plus 3, and y is equal to 4x minus 1. Well, if this is equal to y, and this is equal to y, then I can set them equal to each other, because they're both equal to y. So if y equals 2x plus 3 and y equals 4x minus 1, then that means 2x plus 3 has to equal 4x minus 1. And the nice thing about this method is right now we're going to find the x value that's a solution to this system. You only have the x's. So this is an equation with variables on both sides, and really you should be able to solve this. If you can't, take some good notes. Come to tutoring if you still can't get it. So this is a two-step equation. If you don't know how to solve it, get some help on it. If I was doing this one, there's variables on both sides, so I'm going to subtract. I usually subtract the smaller number. This is a positive 2x. So to undo it, I'm going to subtract a 2x. If I subtract a 2x from this side, I have to subtract a 2x. Here's your wall. Subtract the 2x from that side. Anything minus itself is 0. 4x minus 2x is 2x. This is a two-step equation. Once again, you should know how to solve this. If you don't, get some help. Now you need this by itself, so how do you undo a negative 1 or subtract 1? You add 1. Here's your wall. If you add 1 to the right side of the wall, you have to add 1 to the left. And 2 times what number gives you 4? X is 2, or you could undo times 2 by dividing by 2. X is 2. So there's the x-coordinate of your solution. Now we need to find the y-coordinate of your solution. So hopefully this sort of makes sense to you. If x is 2, I can just go up to either one of these you want. If x is 2, just put a 2 in for the x. 2 times 2 is 4, plus 3 is 7. So the solution to this system is x equals 2 and y equals 7, and sometimes you write it like this. Now that's a solution, because if I put a 2 in here, 2 times 2 is 4, plus 3 is 7. If I put a 2 in here, 4 times 2 is 8. Here, I'll show you this one. 4 times 2 is 8. The question is that equals 7? Well, 8 minus 1 is 7. So that is. Now, just as a reminder, I'm going to show you the first video, or whichever video it was that I showed you. If you graph both lines, the point of intersection is the solution. So, kind of as a review, I'm going to show you how to graph these lines and show you that the point of intersection is at 2, 7. I think this time I will graph them by, they're in slope-intercept form. I'm going to graph them in slope-intercept form. So I'll do them in different colors, I guess. So if I were to graph y equals 2x plus 3, the slope is 2, or 2 over 1, because remember, it's in this form. I bet you can't see that, but it's too high. Okay, well, it's in the form y equals mx plus b. M is, right here, it's 2 over 1, and b is 3. So you begin with b, or the y-intercept, and go up to 3. Okay, this is the change in y over the change in x. So you're going to go up 2, 1, 2, right 1. Up 2, right 1. Up 2, right 1. I would definitely use a ruler for this. And if you're like really lost on how to graph this, then don't completely stress. Really, you're trying to get this equal values. Okay, and this one, you'll be able to see this one better, is also in the form y equals mx plus b. So m is 4, or 4 over 1. B is, what is that, negative 1? So you begin with negative 1. And I'm going to go, this is the change in y over the change in x. And go up 1, 2, 3, 4, right 1. 1, 2, 3, 4, right 1. I can't do it again, so I'm going to just like this. You should really use a ruler. Honestly, I can't use a ruler on this smartboard. I don't know if you can tell, but the point of intersection is 1, 2, 1, 2, 3, 4, 5, 6, 7. So 2, 7 is your solution. And don't forget, if you don't like the way I graphed it this way, you can make a table and pick some x values and fill them in and get y values. That every point on this red line makes this equation true. And every point on the green line makes this equation true, and this is the only point on both lines. Alright, if the graphing confused you, the equal values method, don't forget, is if they're both equal to the same variable, you can just set them equal to each other and solve. So what I would like for you to do is hit pause on your video and try to solve this using the equal values method. And go ahead and try it, hit pause, and then I'll at least make sure, well no, I'm just going to check this tomorrow is what I'm going to do. So, after you attempt this, if you don't know how to do this, go back, and look at your notes, or rewind this video and watch it again. And then down here, on your note page, there should be a place. Write down any questions that you have down here. And we'll go over this tomorrow, so when you come in tomorrow, I'll expect you to have some understanding of how to solve using the equal values method, and I will expect a great effort on this problem. Okay? Alright, come here. Oh. So there's someone here that would like to say hi. Hurry up. Hurry up, it's still filming. Come here, hurry up. Come here. Oh, hold on. Oh. So everybody stand, hold on. This is Hope. This is my big kid first grader, and she is wearing a Boone County shirt because she went to Boone County camp. Hope, tell all my students, do your homework.
Do your homework.
And I will see you either Monday or tomorrow. depending on when I give you this video.